Hello, this is Dr. Strickland. In this video, we will investigate titration calculations. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. So titration calculations are just stoichiometry problems used to determine the quantity of an analyte in a sample. So samples can come in solutions, as solids, as gas mixtures, as kind of gooey things like ointments. So this one is an ointment, but every titration calculation starts with a balanced chemical equation. Now, a roadmap is a great way to keep all the information and steps of calculation organized, a good way to plan the work. But if you have a different way to plan the work that you like better, then you should use what works for you. So this is a sample of a mercuric ointment, and we want to get the organic matter out of the way so that we can take a look at how much mercury 2 is in this mercuric ointment. So the organic matter in this much of the sample is decomposed with nitric acid, and so then it won't interfere with the measurements that we do. So after diluting this mixture, the mercury 2 ion is titrated with this much of a solution of ammonium thiocyanate. So ultimately what we want to know is the weight percent of mercury in this ointment. So let's see what we can do here. So the first thing we need is the equation of the method. And for this reaction, this is the formation of a metal complex. And for an acid-base reaction, I'd expect you to be able to predict products, but not for these because we haven't studied these reactions much at all. So generally speaking, I will tell you what the balanced chemical equation is, unless it's an acid-base reaction. All right, but like with other titration equations, the identity of the products really don't mean anything to us. What we're interested in is these two guys. So we need a mass box and a box under each one. Get us going. Just a basic roadmap, mass, moles under both of them. Sometimes the molar mass is given in the problem, and sometimes you have to calculate it. So what do we know to begin with? Let's see. We know the mass of the sample, and we know more about this guy than we do about that guy. We know volume and a concentration, the ammonium thiocyanate. So we can get to the number of the ammonium thiocyanate. And then because we have the balanced equation and we've got the ratio, we can get to the moles of mercury. And then using the molar mass of mercury, we can get to the mass of the mercury ion in our solution. Okay, and then we can do a weight percent, because this will just be the mass of the mercury divided by the mass of the sample times 100. All right, so like any other roadmap, you can do all of these as separate steps, or you can do these three together and then do that one second, which is what I think. Okay, so this is where we plan the work. But there are lots of ways to plan. All right, work the plan. So we've got the volume, 0 liters. Now, up here in the problem, it was in milliliters. I could have done this in milliliters here, or you can convert it to liters before you start. So I thought this time we'd just do it that way. And we'll use the molarity just as is. And we'll do the molarity in moles per liter. You know, molarity can be millimoles per milliliter. if you wish, ammonium thiocyanate. Exactly 1 liter. So you can write 1 liter and have unlimited significant figures, or you can put as many zeros past that as you like. All right, so that gets us to mole, this first component. And then to get to moles of the mercury 2 ion, we use the molar ratio. And the molar ratio is just revealed by the coefficients in the balanced equation. So 1 to 2. So this has taken us to moles of this substance. This has taken us to moles of that substance, so we can get to the mass of the mercury 2 ion using its molar mass. And I'm going to give it to you this time. And so this is, this is the molar mass of the mercury element. Why is it that it's the mercury 2 ion has the same molar mass? Well, this guy is missing 2 electrons, and electrons don't weigh very much. So that's why. All right, so let's make sure our units cancel the way we think. So liters of solution go, moles of ammonium thiocyanate go, moles of the mercury 2 ion go. That will give us the mass of the mercury 2 in grams. And I got 0.244 with the guard digit of 9. Right, and so this is 3. So to do our fourth step, what we need is the mass of the mercury 2 that we determined, plus the mass of the sample, which was given in the original. So what was the mass of the original sample? Okay, so I want you to go get it. Put in here, divide by 100, find out what the weight percent is, and write me a statement. All right, so pause the video and do that, and then come on back. Back. So we started with 3.776 grams of the sample, the ointment. And when you do the math, this is 6.472%. 4 significant figures here, 4 significant figures there. So, to answer this question, say mercury concentration in this ointment, this mercury ointment. Idea to put some details from the original problem in your statement so you got some content. Mercury concentration in this mercury ointment in weight percent is 6.472%. All right, so that's the basic story on setting up and using titration calculations. If you have any questions about this, please send them to me.